Hey, this is Spencer from Kinetic Precision, and today we have the good fortune to be joined by some experts in something called Git. And we're going to learn what Git is and how to use it, even though we're hardware guys. So let me bring in our guest and expert. Please welcome Ike from Brooklyn, also known as Unix Carbide on all the socials. Hey, Ike.
Hi. How you doing, Spencer?
Did you have a bagel yet this morning?
I have not had a bagel this morning. No, no,
Okay.
no. I'm here instead. So,
And helping us in the peanut gallery. Let's see if I can find him. There he is. It's Dan in Brooklyn. How are you? No, you're not in Brooklyn. You're in Rockland County.
Yes, and hi.
How are you?
Good.
So let's just turn it over to Ike. You run with it, and I'll try to keep up with you.
all right, cool. Cool. So, yeah, getting right into it. Source code control. What is this? What is source code? It's a bunch of text files. That's what code is. It's text. So when a bunch of people are working on software together or doing something together, like Spencer's been doing recently with his HackRH project, right? That code, if multiple people were to be editing it, well, things can get really confusing really fast. People passing around copies of a file, emailing them to each other, posting them in the socials and passing it back and forth. That's a very messy way to work, especially when a project suddenly has more than one file. This could turn into a disaster very quickly. I don't know if folks in the audience have done things with 3D modeling or CAD or different machine things that take those 3D models and do things. But if you're passing files around to each other, everybody knows this can get messy very quickly. So source code management. Git is a source code management tool. We're going to be covering the basics of how it works as fast as we can. And leaving breadcrumbs to the documentation so that folks can figure out how to accomplish a given task very quickly. And then we're going to dive into GitHub, which is it's a company, it's a website, it's where people dump code that ends up in the public domain. GitHub is basically just a way to host a server that people can use with Git. And they provide free accounts and all that kind of fun stuff. But there's a tremendous amount of amazing stuff in there for machinists, for hardware people, for software people, for sure. So we're gonna dive into exploring that so that hey, if you see something that's like a 3D model of a particular thing that you care about and I want people to be empowered to be able to understand how to fetch it, understand how to, if you've made changes that are good, submit them back to someone else, right? And this doesn't just apply to, say, open source projects or public domain things. This is a way to work that companies use. So GitHub makes their living by selling their service to companies as well, so that admins don't have to run their own Git server, right? So that's one way of doing it. You can also run your own Git server if you want to keep everything in the house, but we're not going to cover that today. I'm going to do the examples, some of the foundational stuff I'm just going to do in a Unix terminal because the commands and the words are the same primitives. But I'm also going to then, once we get over to some stuff in GitHub and Spencer's code, I'm going to pop up with the GitHub UI, which is, as far as I understand it, the kind of common way to use Git in Windows if you're not a command line hacker. So yeah, all these things apply. So I have been around the Unix community, in particular the BSD Unix world and Linux, since the late 90s, for a long time. And I've been around a lot of open source software. I work professionally as a infrastructure engineer. And so let me see. I know a lot about different Unix systems and have programmed in maybe 36 languages and know probably none of them well. And I have an obsession with writing portable shell programs, which is a kind of a ancient dark art that nobody should care about. It's not that fun. For the programmers out there, if your only data type is strings, your life is hard. So, with that stated, I've been around source code control for a long time, so I'll dive into then Git and its emergence, because I've been programming since before Git was a thing. Source code control goes back a long time, because as computers, in particular the Unix world of computers, in the 60s, 70s, late 60s, 70s, 80s, proliferated, people needed to manage lots of different code. And the first source code control system was called SCCM. It is long dead. And the old Bell Labs comment about SCCM is your code checks in, but it never checks out. That was SCCM. Later, there were many commercial things in the 80s during the Unix wars. And then into the 90s, a software called CVS became popular, concurrent versioning system. And in all of these things, they were very much server-based, right? So in computing, we have this kind of back and forth over the decades where things become very server-centric, like right now with the cloud. And then the pendulum swings back and it becomes very end computer distributed centric, right? And so CVS was born of the era of things being very server and mainframe centric, right? So when you checked out a version of the code, you only had that one version of the code on your machine. If you became disconnected from the network, the version control system didn't matter anymore. You weren't connected to it. Fast forward into the late 90s, early 2000s, and you get to a tool called SVN, Subversion, which everybody thought was a very clever name. And Subversion was kind of a hybrid of these models. It allowed for a bunch of really interesting features that allowed you to take large code bases, many thousands of files, many millions of lines, and compare them against other branches of the same code base, which was very powerful. But it was still very mainframe server-centric. And then came Git, which was written by Linus Torvalds, who originally written by him. And he also wrote the Linux kernel, if anybody's heard of that. Git's one of the things that I like that Linus has written. I'm not a big fan of his kernel. The Git software was designed to take all the branches that are known and allow a user to download them locally and have a full repository so that they could work online or offline. So this started to blend the mainframe and the home or individual computer models of working with code. So when you commit, now we're getting into some Git learning. When you commit code to a Git repo, you're only doing it on your local computer. You can work for months and keep committing code, and none of your colleagues will see it until you push it up to some central place.
So you use the term repo.
Repository, yes.
Okay.
So a code repository, thank you. A code repository is keep doing that. That's good. This keeps me going. A repo is just a folder, but it's not. If you have a folder full of files that are your code, well, there's your software. There's your stuff. A repo is something in Git that has been initialized. It's a folder where you've used the Git software to run some commands, and it puts an extra little folder inside of there called .git that contains a set of diffs. So Git is based on, and I'm gonna actually just dive straight into Git stuff here. Oh, a Git repo is a folder full of some files, or maybe empty, but that's been initialized using the Git tool, that it can now have a bunch of operations that the Git software can perform on it. And these operations are kind of like when you save a file. They're kind of like saving a file, but they're saving many files. And when you save them, you can save versions of the file. You're saving a version of the file. And this software allows you to roll back and be able to actually go back to older versions infinitely to the beginning of the history of the repo. So every time somebody makes a commit in a repo, that history is preserved. So if you liked the way that the code was last week and you deleted those lines that are very important to you now, you can go back to last week's version and look at it, or compare it to the version you have and pull out the things you care about, which is very powerful.
I have a question.
Yes.
Does the file do the files in the Git repository have to be code? Can they be other flavors of file?
Absolutely not, but there's some big buts there. Big binary files will very quickly make your repository size gigantic and hard to move around on the internet and on your own computer. Very slow, right? So binary files don't diff very well. Let me throw this up because I was going to say that diff and patch are basically what Git's built on, which is 40-year-old software, frankly. And it's wonderful, really good software. Some of the brilliant stuff in the world. Diff compares files line by line, right? So it does a very efficient comparison of one file to another file to figure out which lines are the same and which lines are different and what's different in them. And then patch uses diffs to allow you to take a diff and apply it to a file to say, hey, I have a patch with these 5 lines that have changed out of 1,000, and at line 4, this line is different. And at line 5, there's 2 more lines after it that are this and this, and that kind of thing. So diff and patch are fundamentally how Git works. So the .git repo and what's in a repo, the .git directory in your repo contains really a bunch of patches that are applied to the repo over time to present a linear history of change. Does that answer the question, or did I go sideways?
No, I think I get it. Let me restate it to see if I understand it. File types that are not text require them to be the changed files have to be
The whole change has to go in.
You got to have the whole change, whereas text files.
1 gigabyte binary file of some kind, a picture counts. Anything else that's a binary counts.
A Fusion 360 file.
No, Fusion 360 files are primarily they're text based. They have a lot of text in them.
That's interesting.
Fusion 360 files are commonly kept in repos.
So, but when you keep text files in the repos say, yeah, just like the other one, except line 17 has a semicolon instead of a colon. So it just has that little teeny bit of information instead of the whole file again.
Yeah. And one thing about Fusion 360 is you don't see it as much in repos, or you don't see a culture around putting it in repos, because the tool itself encourages you to put things in Fusion 360's cloud. They want to save your files.
How about, of interest to our community is G-code, right? G-code is pure text.
Pure text.
So,
pure text. In some of the 3D printer community that I'm around Clipper, the firmware to run printers, and the myriad of other softwares, there are many macros, and even for slicers, the macros for what your start routine should look like for your 3D printer. I'm going to put a little squiggle here to bleed the line, and I'm going to move like this, and I'm going to wipe it over here. Those macros are commonly kept in repos, right? And people keep their own files in repos and then share snippets with other people. And some people make full-on software packages like, hey, if you want to print like I print, here's all of the stuff in a Git repo. So yeah, G-code is absolutely great in a repo.
That's pretty cool.
Yeah. G-code, and there's a lot of it in GitHub. Other things, STL files, totally great in repos. Stereolithography files are primarily text. So the printable output of something, that if you're going to use STL files, they can go in repos. What's the format that Robin Rossetti likes so much? The high quality stuff. print with? I've forgotten the name of it.
Usually there's say
Just
again.
using the step file.
Step files, right?
Okay. Yeah.
Yeah.
Those,
Yeah.
back repo.
Yeah. Step files. For example, the Prusa slicer, bamboo slicer, etc.
Yeah.
can now use step files directly, and in some cases they're better. And those are also, you're saying, those are also text based.
Yep. Also G code for CNC machines. So this varies a lot based on the culture of the machine that people are using. But there is a tremendous amount of G code that is specific to CNC machines that you can find in GitHub as well. In GitHub, and I challenge everybody to go find it, there are even small CNC machines that can be 3D printed that are fully all of the source for everything to print and all the instructions to build them and all of the firmware to run them and all of the stuff are in a project in GitHub. And I forgot the name of the fun one, but it's a cutie. But that's kind of like all of it, everything you can think of in a project. And all of that fits into a GitHub repo. The 3D printer I've been building, a Voron, that's all in GitHub. User mods are in GitHub. People's designs where they have forked the official Voron build and said, I want to do some different things, they're in GitHub. It's really neat.
Pretty cool.
Yeah. So here's the thing that the Git software, getting back to that this really allows you to do. And I'm going to go back over here to the Git book. So when you're on the Git, basically the Git website, I'm not doing my own slides. I want to just point at the docs because they're really good. And the Git SCM site has great documentation right here. The Git book has kind of, task-based things. Like I want to learn about branching and merging. They've got a nice chapter on that. It's pretty well written. And we're gonna dive into it. Or if you want just the command reference, it's here. What is Git branch? What are all the things I can do with Git branch? What are all the features? Right. So this documentation is absolutely fantastic as far as getting into this. What I wanted to talk about then was branching and merging, and then give some real world kind of example here. Because in particular, some of the work, Spencer, some of the stuff you've done in GitHub with HackRH, like this thing's ready and running. There's people hacking on it out in the world.
It's true.
Yeah, when somebody finds a bug.
Just to put a point on your pencil here, when you got me to use Git, and I published the first, kind of working version, Dan went ahead. Not only did Dan, now this didn't apply to the 3D models, but it did apply to the code. But Dan printed the little 3D workstation that I made, downloaded the code from Git, and had the thing up and running.
Yep.
And the only thing I did wrong is I should have had the 3D models on Git also.
Yeah.
That was pretty cool.
Yeah, absolutely. And you can put all of those things into the project. Yeah. Let me talk about the code and how it splits and branches and merges. I'm going to go to the fine whiteboard here and try to make this big as we go. Okay, so let's take Git has two versions of time that it keeps that are very important. And these are just concepts. Then we're going to dive into just using it in a second. But there's two versions of time. If you're going to record every change, here's a moment where this is the first moment where there's a file that Spencer, I'm going to say that you made this. I'm going to use the audience here. Spencer and DBX here. So you made the file. That's great. Now you've committed it with a message, right? You've given some message. Hey, I made the first one. Cool. Now, I'm going to just gloss over, you've pushed it to the remote repo, and TBX and I are both capable of fetching it. Now we're going to edit the file. So now there's three of us working here. So we got Spencer, TBX, and Unix Carbide. And we've all made different changes to the file. And yours is now round, and yours is now a triangle, and mine is, a diamond. And it's no longer the same code. And that's now how are we going to deal with this? I changed a few lines in the middle. DBX changed a few lines at the end, and you changed some lines at the beginning. Well, we all now can commit. What we should have done here is to make a branch. So using the Git tool on our local computer, we can make our own branch of the code base. The master and main branch is very important because that's the main line. That's the first one that everybody gets when you fetch the repo. It's also marked as head. I believe the defaults in GitHub nowadays are to call the main branch main. Okay. So with all that, you can make a branch and name it whatever you want locally. Doesn't really matter. And now when I push this branch back up, the code has several copies of branches that people can now go download. They could go download my working branch or Daniel's working branch, or I'm going to say you're going to keep working on master for a second, Spencer. Fine. These are all different. The code is all different. You can use commands like git diff, which is available in the GUI and the command line version. Git diff can show you what files and what lines have changed in diff format, right? It's very, very nice. So you can get a look at like what changes were made very quickly. The idea of merging is the idea of taking one of these branches and going back into the main branch. So I'm going to draw that. Say that's blue. And let's say, Spencer, you don't like my branch. The code I wrote, you're never going to incorporate that. That was silly. Why would Ike in the HackRH project, why would he try to build a, I don't know, a chat GPT interface that plugs it in and lets you ask questions make a gateway to chat GPT from your,
Dude, I don't know. It sounded pretty good, actually.
I mean, yeah, if that's a feature you think is neat, then you can merge it in. But let's just say you're like, hey, hold on a second, buddy. That's a little silly. Whereas DBX is really awesome. He actually just simplified or fixed a bug in, say, time, the way that it fetches time or something useful. Cool. So git merge allows you to take this code and make it another commit on the main branch. So it will appear as whatever commits that DBX made in his branch of the code will now be tacked on in a linear format. I mean, in a linear manner on top of the changes that have already been made. And that's a permanent change to this code base, right? You can revert it. You can revert it a million ways. Some ways that erase it, like when people accidentally put passwords in. There are ways into a piece of code or some other piece of information that you want to just delete permanently. You can do that, but in general, you're always adding to the timeline, right? So if you wanted to revert this change because you realize, I like the way it did time before, that would be just another commit. So it leaves that change in the history. Somebody can go back to that change and refer to it or find it, right? And figure it out. Studying code bases, in particular of large Unix operating systems, there's major academic kind of sociology work that's been done where people have gone in and looked at just the commit history to understand the context for what was being made at that time, right? Which is pretty neat. Does this kind of branching and merging stuff make basic sense so far?
I think so.
All right. I'm going to call out one thing that's very important here about this that confuses a lot of folks when it comes time, but it's really, really simple. Git has two concepts of time, okay? there is wall clock. So Unix Carbide, sitting at his computer, committed this to his repo at such and such, whatever the wall clock on this computer is at that moment, right? And then there's the second version of time, which is the linear order of things. Okay, so I could have gotten this done before DBX's change, and then let's say, Spencer, you decided, that ChatGPT thing is funny. Let's bring it into the code base. So in time, I made mine first, but now it's in a linear timeline that it happens date stamped after the other changes.
Mm-hmm.
All right. When people look at the history of a repo and they're trying to understand things, this can often trip people up because you're looking at timestamps that are not linear. That's wall clock. That's when the human said, "I commit this," not when it was merged. Does that make sense? Are there any questions or thoughts there?
I could see where the confusion would come in, and that makes a lot of sense. So I wrote down the terms wall clock. Is that a term of art?
That's a term of, yeah. I mean, I just think of I call wall clock like the time on the computer.
And then versus the linear order in the main branch.
Correct.
Got it.
Correct. Which is another representation of time or ordering of operations. Yeah. Yeah.
Completely. See, I'm watching Loki now, so I'm starting to understand his problems.
Loki? What? What's
Loki on the Marvel in the Marvel universe.
Oh, yes.
Dealing with changes to the main branch and then alternate universes, and it's like, this is it. They just needed GitHub, and they would have been all set.
I've been in project scenarios where projects that other people have done went on for maybe a couple years, and that body of work was merged into a code base at the end of that couple of years that they had used and done other things with it. And things can get very mind warpy for people reviewing, like, what's going on here? Like, that person doesn't even work here anymore. My goodness. How are they committing to the repo today? Right. Yeah.
Okay. I look forward to that. So, of course, the folks that we're talking to are mostly going to be either individuals or small organizations, like, a small team.
So let's get on to some branching and merging fun. What is it? 35 minutes. Yeah. So we've covered branches and the program. Let's go over to GitHub for a second. I'm going to pull up a different window just to show what GitHub looks like your first time walking in. So this window, this is what GitHub, the website, looks like when you first get here. So if you have not already and you're watching this, sign up. An account is free. They require your email. And you'll make an account. And there's a social aspect that they've tried to really push in the way that GitHub works. That's great. We're going to look at, I'm going to pretend you've done that, and we're going to go look at, let's see here. We're going to look at GitHub. This is what GitHub looks like. If you want to start a new repository, there are great instructions for how to do so. We're glossing, just for the sake of time, we're glossing over a bunch of the Git kind of commands and basics there, just going straight to the meat of branch and merge, and then we'll look around in GitHub for a bit. Let's go to Kinetic Precision Hack RH. This is a repo I was invited to see, right? Spencer, if you have eventually, if you make this public, then people can see this with a read-only view anytime they want. Any human on the planet who can connect to the internet and reach this.
We'll be getting there pretty soon.
Yeah. I'm going to focus, though, on collaboration demo. So this is github.com Unix Carbide collab demo. Anybody watching this video is free to connect submit pull requests, mess around with this repo. If you request that you want to join it as a contributor, I would be happy to allow you to. This repo can be broken and twisted 10 ways from Sunday. I don't care. This repo shows that there are right now 2 branches, which is not a lot. And you can view all of those branches if you want. Let's look at a commit history. GitHub offers a lot of things that are really nice, like a clickable browser view of all of the things we just talked about, like commits. So this is, let's look at the commits. Yeah, this shows 1 commit. Let me look at, there we go, 6 commits. So these are the commits, and these are commit messages. Where this is one where I pushed a new file. It's all plus signs and green because I added a file that are the presenter notes that are supposedly going from today to talk about Git, right? But that was 1 commit, and this is all on the main branch. But I've got this other branch that I made. So locally, I ran git branch. I gave it a name, and then I called it add some 3D files. You can call it anything you want. Different projects may have a rigid or more or less rigid way of naming conventions for branches so they don't get lost, but it doesn't really matter too much. So this branch has 2 commits ahead of the main branch, and this shows what those 2 commits are. You can click on that and see a diff, and one of them is adding a file. So I added a binary, and this thing adds the good, fast, and cheap dice that I made for a moment. And I'm adding this funky little 3D printed object to this. I added the original SketchUp file, which, yes, that's text. And, oh, I'm sorry, it says binary file, not show. It's binary. Okay. And then an STL. Well, it says binary file. Okay, not shown. So it's not going to show the diffs. So it's not going to, these aren't going to diff out. But GitHub will show you that pretty quickly. So these 3 files, ooh, this is kind of a bad one because there's no text in this change. Let me see here. I think we're going to have to do a text in this change. So I made what's in GitHub called a pull request. GitHub allows you to do some really funky stuff that the Git tool, because they're running this big kind of collaborative universe, they've made some additions. So when you're looking at somebody's repo, you can do a thing called fork. This is my repo, so I can't fork my own repo. I did fork. Did I fork? No, I was added as a user.
You could play in my repo.
I didn't fork it because you added me as a user. I forked recently. Let me see. What did I fork? Clipper. Yeah, the Clipper software, because I had a patch I wanted to make. Okay, here's a great example. Clipper is a firmware for running 3D printers. I had a change I wanted to make. Some of the build scripts had references to old Python 2 that were no longer working or relevant. So I made a fork of I'm not a part of the Clipper project, and I'm not a committer, and they don't let me just commit to that project. I don't even know any of those people. But I cloned the entire repo, and now I can do whatever I want with it. It's mine, which is neat. I can make my own local changes and take the whole software and incorporate my ChatGPT interface so that my 3D printer can ChatGPT. No, I could do dumb stuff, and it doesn't matter to the original authors. It's fine. Like I can make whatever I want. If something's useful, like my little fix to their documentation, I took that repo and made a pull request. Yeah, I made a pull request that I pointed at their project. Okay, so when I made this pull request, GitHub allows you to make these things called pull requests, which can span different projects.
Now, is a pull request you asking for their software?
No,
could
a
you,
pull request is you submitting a change of yours and asking the original people to review it, right? So in this case, if we go over to GitHub Clipper 3D and the Clipper repo, somewhere in the many pull requests they get, because it's a very popular project, author, me. Okay, they haven't looked at it yet. That's okay. They're busy and my change is not that important. But I made a pull request based on the changes I made over to the side without their knowledge or caring.
Mhm.
I was able to submit a change, and that change is these lines. I took out this line and added this line. And in this particular case, just changing Python 2 to Python 3 does work, and I tested it. Kind of an important one. It's really annoying when you have to bang your head against the wall. So I'm submitting this to say, hey, this will make your docs better.
Gotcha.
And then this one is actually a radically different line because the runtime for Python is totally different, the way that this is explained. So, but in both of these cases, they published on their world what they want. They want a self-review. If no reviewer picks it up, they want someone to self-review. So I did that, hoping that these very small changes would get in. And that's it. That's really it. So if somebody wanted to, Spencer, for HackRH, if you put it out openly in the world, somebody could fork the HackRH, do whatever they want with it, change it around. And if they did something that they think is that you would like or that they would like to see in the what is called the upstream, you are the upstream. They're their repo came as downstream of you.
Yep.
If they want to submit something back upstream to be part of the main project, they could submit a PR to you, right? And so in your project, I've done that, and you approved the PR. Yeah, adding a shebang to the Python code, which doesn't really change much.
Okay,
But
hang on.
it
You
allows
gotta define shebang.
shebang. So the shebang, here it is, shebang. That's why it's called. I don't know a better way to put it except that is a pound sign and an exclamation, and followed by a path to something to execute. So on a Unix machine, now we're not talking about Git. We're talking about Unix and computers in general. In most programs, that have an interpreter. They're not compiled like a C program or Go or some other compiled language, but in an interpreted language like Python or Shell or Perl or Ruby or many, many languages. This is the first line, and if this program is executable, your computer will try to go find the Python binary and run this code with it, right? That's what the shebang is.
Is
So
there?
yes.
Can you just? Frankly, I can't see it on the screen clearly
Oh,
enough.
make it bigger.
Can you
Yeah,
do that?
make it bigger, which means making it smaller.
There we go.
Hey,
Okay.
there we go. There's the shebang. Pound exclamation point,
Okay.
and
Got it.
then user bin env will help us find the right system Python, whatever's been on the path. This is the most portable way to do the Python interpreter.
Got it.
And so this allows this program, which if you run what you run, you're running this through the MicroPython interpreter, which is already it's already handing it to the Feather board that you're working with.
Yep.
It's handing it to it in a place where Python is already going to be executing and knows that this is the code it's going to run. But on a normal computer, this same code can run, like normal meaning just any other computer. I could run this on my Mac or on a Linux machine or on a Unix machine of any kind. If it has this shebang, it'll find Python now and it'll run the code below. And most of what you've written is not Feather specific or you know, a lot of the things in here could run on another machine, which is neat. So that's what this change request is. Not focusing too much on the change, let me focus on what this allows. This allows us to have a conversation. So I'm not saying that you shouldn't have asked that question, but you could ask that question here and just be like, hey, I don't know what this is. Explain why you want this change to my code.
Mm-hmm.
And now it's on me to give you a cromulent explanation for why I think this is important. And, you know, this is where it gets social. We could argue it out. Some DBX could come in and be like, that's a stupid change. I disagree. And I'd be like, okay, well, Spencer's code. Spencer, what do you think? Me or DBX? Who do you like better? You know, that's how good engineering really works, right?
Yes, absolutely.
So this also allows us to request reviewers. So if other people are associated with this, you could say, hey, I really want DBX to look at this. I want somebody else who knows this code base to look at this, or somebody else, whatever. That doesn't mean they're obligated. It's just a request. They might get an email from GitHub saying, someone requested you review something. Whoopee. But when you're down and done here, oh, this has conflicts now. So this has been sitting so long that I'm assured that your main branch has changed enough that there is some kind of conflict. Right? So we can't just merge this. But usually there's a big merge button right there.
Gotcha.
And that's the target that I want to leave this topic with is there's a merge button in GitHub that makes life easy. That is very simple. It is the same operation as using the command line to say git merge. And it is the same operation as using the GitHub. There's a button inside of, I promised I would pull it up, so why don't I pull it up? In GitHub desktop, there is merge in here somewhere. And actually, I do not know quite how changes. Which origin? Let me see if there's a. So okay, here's the branch. Here we go. What's the name of my branch? It was cleanup conventions. This was the branch we were just looking at in GitHub, or that's the name of the branch. Hold on. Current branch. So this is telling me actually that there's already a pull request. So the GitHub client is saying there's already a pull request. Go look at the pull request. They want you to merge it in the browser. But the GitHub, this tool will direct you towards approving a pull request by merging the code in. Yeah. So basically, in here, if you're interested in this particular change, Spencer, this is where you put the onus back on the requester to say, hey, your code, by the time I'm looking at it, it won't merge. It doesn't even, it won't merge. So will you please go fix this? And I can go do a thing called rebasing. I'm going to just cover the quickest version of rebase in the world. If I have been working on a piece of code and the code base has moved on ahead of me, so let's say I forked here and the code has continued to evolve, right? And you're all the way down at this version down here, like version 5. And I've been making changes and I have a substantial number of changes and commits, but I don't know about any of these. Right? So this is where it's on me, the person who's made a branch, to rebase. That's legible, to rebase. And what that will do is if I'm down here and I run the rebase operation, this will snip this whole branch, make a copy of everything that you have already done. So if this is A, B, C, D, then rebase is going to take and move right here and insert A, B, C, D, and move all of my changes down in time after the rebase operation. Okay, so basically it's me saying, cool, I'm going to move my code after all of this, even though I've been working over here for a while. It's a very, very, very powerful thing. So now if I have a change that I've made that wasn't aware, that conflicts with a change over here, I can find it very quickly and easily on my own without bothering you.
Gotcha.
And then I've got something that will merge in cleanly. So that's probably what I'm going to do for this branch. Go back to you and say, hey, Spencer, would you like to put this shebang in your code? And your big question should be, won't it break my Circuit Python? And my answer will be no, because it starts with a pound, which in most languages, including Python, is a comment. So if you're already running code, a shebang is a safe thing to insert, because if you're already in the interpreter, it gets interpreted as a comment.
And that's no accident.
No. That's a design that goes back, a design decision that goes back to, I believe, 1971. Unix stuff. Anyhow.
Pretty cool.
Let me think. Does branching and merging make more sense now? Is that, do you have any questions about details or substantial things that I kind of glossed over?
I can imagine. I can imagine in a complex software development, we have multiple software developers, and it's a big project that using the tool like this is utterly critical.
So here's actually, I'm glad you framed it that way. It's not just for big, fancy, complicated, or lots and lots of people kinds of projects. An individual, once you start working this way, an individual may, here's something I've done in the last week. I start hacking on something, and very quickly I've got 4 files, right? Program and maybe 3 library things that are part of it, broken out of it. It works, it runs. And now I'm going to take that and make sure that it runs. And it runs on, say, Linux. And it works just great. Now I'm going to run it and go let it go do something. Now I want to make sure that this runs on, say, OpenBSD, which is a different Unix, and hey, there's a lot that could be different. And so I can make a branch and go get it running on OpenBSD, and oh man, wow, did I have to do some different things. Some things are very different between these computers. Now I can maintain a branch for each operating system until I can take the painful time required to make this thing portable and run as the same code on both systems, right? Because I may need to write a function to say, well, you know, the sed on Linux that I'm calling in this shell bootstrappy program is GNU sed, and the sed that I'm using on this other program is, you know, an older sed or a different sed, BSD sed. I might have to make the 2 pieces of code that I wrote into a if-def. I may have to do the evil thing. If I'm on Linux, do this. If I'm on a BSD, do that. And turn that into a function that I call to get the operation I need done.
You used another term. You used another term called SID.
SED.
Ed.
SED is a wonderful text processor.
SED.
SED. SED is the stream editor. And I believe it was written in 76, 77 originally, maybe later than that, but I don't think much. The stream editor, early Unix machines had needed an editor. The first editor was called Ed. Ed is pretty cool. I haven't used it in a while, so I forgot all the commands, but these were command line text editors. This is before anybody had ever seen a text editor, right? This didn't exist as a thing in the world. So SED was the stream editor. So we got partway through the mountain of things that I wanted to get through today. Everybody now should be an expert on using Git and GitHub and be super comfortable jumping out in the world. No, I think anybody who's watching this, and this is as far as you're going to go with all this, Spencer, are you going to make some channel in your Discord somewhere for Git questions?
Yeah, we have to.
Yeah, there's people like me, DBX. There's others. Spencer, we're going to make you the experts. Your Discord. So, but there. I think it's totally reasonable jumping into a repo to start doing stuff and asking people how to do it.
Well, I
If you
think
find
that's the next
something-
step.
Yeah, if you find something in GitHub that you want to build, or you think like, oh, that design's great, but I could do it better, and here, how do I make a PR, and how do I check out?
So
We're
we'll
there for
start.
questions.
We'll start doing this more seriously. I'll get more rigorous on the Hack RH stuff. And would you come back and do part 2, and we'll keep going on this?
Well, I'll come back anytime. Yeah.
Okay, you're awesome. Thank you for
Yeah,
being
you
here.
too. You too. I really
And-
appreciate this Discord and the weird amount of fun that we've all generated out of it. It's pretty
It
cool.
is a weird amount of fun. So let me just put the ribbons on this. Thanks, Ike, and everybody. Keep an eye on our YouTube stream and also on the Discord for the next episode of Git for Hardware, folks. Thank you, sir.
Rock your day.
See you later.